record this class on Twitch, which should work better than Zoom. So here we are, we're at 129S. Now, I planned originally to be finishing Chapter 3 today, but Chapter 3 we finished it last time. So all I want to do is demonstrate the first few projects here and make sure everybody's going ahead on the projects. So one thing I want to do, people that come in Zoom should just go to twitch.tv. So let me make sure and repeat that message now and then. Go to twitch.tv/sambound. There. And I'll put that, here, and I'll try and repeat that in the chat now and then, because the people on Zoom will probably be confused. All right. Anyway, so here we are. So I want to start by just demonstrating several projects here. Now, the first one is probably the SQL injection. That's where we left off. And this one here is really important. So here's the SQL injection, and like I say, it's good enough for a lecture all by itself. So here's SQL injection, and this page shows you a series of demonstrations. There's several SQL databases connected to from this page. And so the point of SQL injection, in the previous project we did command injection, where you inject, I'm just looking to see, we hear you on Twitch, good, okay. My comments are way over there, I'm getting used to it. Okay, so in the previous classes we did command injection, where you inject bash commands that you can execute right on the server, things like ls and so on. And those servers, those commands are in a relatively familiar language to many people, and the one you learned if you did the Linux Journey projects. Let me just, I see more people appearing in Zoom, so I'm going to repeat this message to them, telling them where to go. All right, and so the only trick in SQL, we're going to do the same thing. The only trick is you have to use this weird language called SQL, which is a structured query language, and the point of it is to let you see data stored in databases. It does not have general use commands. Everything refers to the data stored in databases. So here is a place where we can put a raw query. And this is not something you would normally let anybody have access to except the system administrator, but we're going to, in this database, we're going to just practice here. So I'm going to reset the server here. That just removes any changes that a previous student might have made. And so the simplest command is just show something. So I can show the databases here. Whoa, the copy command did not work. Let me try again. That should be copy. That should be paste. There we go. So I show databases, and you'll see there are two databases. One is called information_schema, and the other is called widgets. Now, the information_schema database is constructed by the MySQL software itself. And it has widgets is where the company data is. Now, I see a question in Zoom, so I'm going to repeat these instructions and see if that helps. All right. Anyway, now, all right. So since the SQL software creates this information schema database, and it always has the same name, you can learn a lot by just querying that database. Now, I could just show tables as well as showing databases. Databases are a big container, and tables are the small container inside the big container that contains fields. And if I show the tables, I only see the tables in the database named widgets. There's a table named employees. Yes, Warren Lee is not willing to go to Twitch. Keeps saying he can't hear any sound or see any video. I was afraid this would happen, so let me try and put a page up that says the same thing. Go to and try to project it in Zoom. And we'll see if that does any good. All right. Let's see if I can There it is. All right, perhaps that will help. We will see. All right. Anyway, so this shows me the employees table. Now, you can also just select simple things. You can select just a number, 1, and it will repeat that number back. So it'd be select 1, and the result is 1. Not much of a surprise there. You can select fixed things like peanut, and you can combine two things together, like concatenate peanut and butter. This is where you can create immediate text. Peanut and butter is peanut butter. All right. You can use either one for questions, Kunal. Let me know. I'm watching them both right now. And if this works, I'll probably abandon Zoom entirely. Good? All right. So that's it, selecting immediate things. Now you can also pick individual characters out of it. So for example, if I go here, it's going to select the second letter and 2 letters starting at that point in peanut. So let's try that. All right. So it's starting at character 2 for 2 characters. So that's 1, 2, the E and the A is what you get with this kind of select. All right. Now, here you can have a comparison. It's going to tell me whether that is equal to E. And the result is 1, which is true, which means that starting at the second letter, picking off 1 letter produces E. This whole quantity is therefore the letter E, and that equals the letter E. Okay? But if I change that to, say, 3 here, then I'm going to get the result 0, which is false. This is very common in many computer languages. 1 is true, 0 is false. And now I'm picking out the third letter, which is A here, so it's not equal to E. All right. And now I can select data from a table. Now in this case, since I can write an arbitrary select command, I can have as many columns of answers as I want to. So I can select everything from the employees table with this command by just using star. This is a handy trick here, but it's not going to be that useful for real SQL injection because you can't control the number of columns normally. But here I get 3 columns, ID, name, and social security number, ID, name, and SSN, lined up like this, so I got 3 pieces of data for each record. These are called fields, ID, name, and SSN, and this whole thing is called a record for one entity, which is Bill Gates. So that's all the information from employees. Now, since I could also get just one field, like just the ID. And then I just get one answer for each employee, 1, 2, 3. All right. Now, I can select more than one field, like name and ID from employees. Then I get 2 answers, name and ID, for each employee. Now I can restrict it to 1 employee only, and this is what happens when you go into something like Facebook and you see your profile. I can put where, can use limit to bypass column limit. Limit just limits the number of records that come out, but you can't use limit to change the number of columns, which is going to be a problem later. You're on the right track. All right. So I have employees. Now I can do where ID equals 1. And now I'll get only the record for that one person. So if you go to your profile in Facebook, then you're seeing the data about just you. And the point is the developer will fill in most of this, and you will just fill in this value, like your number or your name or something. And all the rest of this will be fixed, put in by the coder, so you can only get the information about one user, which would be set to be the one you have logged into in a properly set up system. So now let's try this one. I'm going to concatenate name ID from employees. Let's start with this much of it. I'm going to use concatenation of name and ID. So now I'm going to get one field, and it's going to have the name followed by the ID, all mixed together in one column. So this is one text column and contains two pieces of information. Now I'm going to set that where the ID equals 1. So I'll only get it for that one user. Okay, but now I can add more to it. I can say or cat equals dog. Now cat never equals dog, but with an or, either one of those conditions will be true. There is a record where the ID equals 1, but there is no record where cat equals dog. Now if I made this and, then I would get no results because both of these conditions have to be true. ID equals 1 and cat equals dog, and this condition is always false. All right, but I could also do this. Let's just get the whole thing. All right, here the condition is ID equals 1 or cat equals dog or 2 equals 2. And now I get all the data because this condition is always true. And since I'm using or, if any one of these three conditions is true, it's true. So I get the whole result of the table. All right, now you can insert data into the database this way. I don't think I'll bother, but you can. And now let's find out, in order to do all these things I just did, I had to know that the name of the table was employees, and I had to know that the name of the fields were ID and name. And those are all names chosen by the developer that set up the database. So I might, if I don't know those in advance, I have to find them. So I have to start with things like this. I have to look at information schema because that's what's always created automatically with the same name. So here, I can get everything in the information schema tables database, and you'll see there's a lot of things in there. All these capital names are the ones automatically created by the system, and there are hundreds of them. But way down in this case, I'm just seeing automatically generated things. All right, I think the other stuff is in there somewhere, but it's not easy to find. So what's more fun is here, I can get the table name from information schema tables. This will get me the name of all the tables. And now I see a lot of tables, and these are all internal tables used by the SQL database. And down at the bottom, I see the one table in lowercase letters that is not made by the database. That's employees. So all these are just internal housekeeping things, and that's the one that would actually contain data that are of great importance, like Social Security numbers. So I've now got all the tables, and now I can get all the columns. So here, if I select from information schema all the column names, I'm going to get a list of all the column names, but once again, I've disconnected them from table names. Now in this case, the same kind of logic will work. These lowercase names are in the table because this is a very simple database with only one table other than the automatically generated one. But in general, this information this way is not terribly useful because the column names are not connected to the table names. So what would be better would be to restrict it to the table name of interest, and that's what this will do. This will tell me the column names for the table named employees, which is the one that contains data I probably want, like Social Security numbers. And now I can see the table is named employees, and the columns are ID, name, and SSN. And that's the information that I need to do these things up here, where I can now find out anybody's Social Security number. So there's a couple of challenges here, and you'll find that some of these example queries will give you the answers to these. You may have to modify things, but in this case, I don't even think you have to modify them. You just have to find the correct one up there. You can get somebody's Social Security number out of the database, and one of those long lists of capital letters includes this young make thing, which is one of the many automatically generated things. So now, that was just how SQL works. But as I said, you never get the opportunity to do this, where you can just put in a select query. That would be crazy. Nobody would let a customer have that kind of access. What you get is something like this. You can search for a user by name. So I can search for, say, Bill Gates. And if Bill Gates is in the database, it finds him. And then it might show me his picture and email address or something if this was something like a social network. That's what you might have. But suppose I have a name like this one with an apostrophe in it. Now I get a SQL syntax error. This is what you want. When you see a SQL syntax error, that means you have confused the server to where part of the name you put in is being interpreted as a command. And I echo the query, which is not something most servers do. So you can see what happened. And here's the query. Select name from employees where name equals tip O. Then this apostrophe that came from me matched this apostrophe the developer put there. And now it tried to find a name called tip O, and then it tried to take the word Neil and interpret that as a SQL command, like where or something, and that's not a valid SQL command, so it quit. But the point is, part of the data that I put in was interpreted as a command, not data. This is command injection. Now all I have to do is write a more careful name that will include a legitimate command. So if I put in Sam here and search, there is nobody named Sam, so I get no result. It's not an error, it just has no result. But if I do this, Sam apostrophe, or 1 equals 1, and then the pound, then I get all the names, because this is looking for this condition. Name equals Sam, which is never true, or 1 equals 1, which is always true, and the pound sign starts a comment, so it eats up that extra apostrophe that would otherwise cause a syntax error. So by injecting this carefully crafted name, I can get all the names in the database. And now, one thing I can't do, though, this was only intending to return a column of names. So if I was to try to get, well, right now, that's all I'm getting right now is a list of names. If I wanted passwords or social security numbers or something, this kind of injection will not do it, because I was only able to control this much of the query. This part, where it said select name from employees, was put there by the developer, and I don't have control of that. So I'm able to inject something, but I'm not really able to get anything I might want, like a password. So I need to try for a better injection. And the better injection is down here. This one here lets me do this. Now it selects name from employees where name equals Sam, and there are no results like that. Union select one. Now the union operator performs 2 select queries and adds the results together and puts it in a column. And the problem, which I mentioned before, is this is only going to select one field called name. So if I select 1, it'll put a 1 in here and I see it. But if I tried to select 2 things, like 1, 2, then I'd get an error. The use select statements have a different number of columns. So if I wanted to get, say, name and password, or password and social security number or something, I can't get 2 things in a column that only has 1 column. And I can't change the number of columns because I do not control this part of the command. So that's the trick. And that's why if you use automated SQL injection tools, usually the first step is they'll do a whole bunch of selects that just try numbers, 1, 2, 1, 2, 3, 1, 2, 3, 4, 1, 2, 3, 4, 5, to find out how many columns there are, and then craft future queries based on the knowledge of how many columns exist. But the point is, as long as I obey the rule of only having 1 column of results, I now can put in a select query of any kind. So if I wanted to know what the names of the databases are here, I could go up here and find show databases, maybe, I don't know. But I'm going to go into tables. Here's the one that shows me the names of all the tables. So I should be able to run that one here. There. And now when I submit it, now I get all the table names. Because so I completely control this select command here. So I can now inject complete select commands, the only limit. And so now I see there are two tables, one called employees and one called passwords. And now, if I want to find out the fields in the table called employees, I could go back to this one. And I could get the columns from, say, the employees table by putting that one here. There. I should be able to make this bigger. Come on, there we go. So that should select all the columns where table name equals employees. And so now I can see the employee table has ID, name, and SSN. So by going in this manner, you can now construct queries to find these things. And that should get you started. Here you can try, if you want to, use the Linux tool SQL map and practice using it on a couple of targets. And then I want to talk about blind SQL, because this one is more realistic. By the way, this one here is in fact quite realistic. This situation you find fairly often. Something like 10% of all servers are vulnerable to SQL injection. At least they were true a few years ago. Let's talk about blind SQL though. This is a common situation where there is a query being made and there's some kind of page after the query, but it doesn't print data that came from the tables. So if I search for Bill Gates here by name, it tells me user Bill Gates found. So that's all right. So far it looks the same as the previous one. But if I search for X, there is nobody named X, so I get no result. So that's also not surprising. But if I set up this query, which is designed to always be true, I would expect to see all the names. But what happened is I put in this name, and if you read this the way the SQL parser is going to read it, it's looking for name equals X or A equals A. So this is always true. So this condition is always true, so it should select all the names from the employees. And it probably did that, but the result does not show me any of those names. The result just echoes what I put in. So I get a page, and I can tell whether something was found or nothing was found, but that's all I get. All I get is a yes or no answer. If there is a result, then this condition was true. If there is not a result, this condition was never satisfied. But I do not get any data from the database, and this is called blind SQL injection. You can inject commands, and they execute on the server, but you cannot see the output of your command. This is a very common situation. And I see someone else appearing. Oh, they're probably going to find it because I'm sharing that page. All right, so let's try this. So this is a condition, X or A equals A. If I change this to B and submit, now I get no results. So if I see a result, this condition was true. If I don't see a result, that condition is false. So now I can ask a yes or no question. And this is like the game 20 questions, where you ask yes or no questions to find an object. So for example, if I want to know the length of the database, I can craft this query. And when I inject this name, it's going to have no result, which means the length of the database name is not equal to 1. So I could now try 2, 3, 4, and 5 to find out how long the database name is, or I can be a little smarter and I can say, I can use greater than and less than. So is it greater than 6? And it is not greater than 6. So it's somewhere between 2 and 5. So I can narrow it down that way. So you can now ask questions. You find a link to the database's name. Then you can find social security numbers with this kind of thing. You're trying to find Bill Gates' social security number. So you can use queries like this where you find the name and then where the substring of the name has this letter in it. So let's just try a couple of these. If I do this, union select one, I can do a union. And so I look for a name equals X, and from what I did before, I know that is never true. And then when I do union select one, it finds a 1, so it had a result, and when it has a result, it echoes back my query. Now I see a question over here. What logic is making it behave this way? What is the backend SQL? You can see it right here. This is the backend SQL. That's why it prints here. This is the actual command executed on the server. And all I did was write a PHP page that constructs this command. It takes this information, and then it adds this from the user, and then it puts another apostrophe there. That's exactly it right there. So this is the way it works, and this is the most common kind of SQL injection. And it executes on the server. So now I know it executed this select one, and it found one record. So having done that, I can now try selecting name from employees, where name equals Bill Gates. And if I do that, it will find a result. All right, I'm going to put a pound here. All right, so if I run that one and submit it, it found it, which means it was able to find a name. There was a result. There was a name where name equals Bill Gates, which is not surprising. But if I want to actually get information about that, I need to add more of a condition, and that's what this whole mess is. So let's talk about this one. All right. If I run this one, now it is selecting name from employees where name equals Bill Gates and substring name 11 equals B. So it is checking to see if the substring of the name, the first letter starts with B. And it does, of course, because it's Bill Gates. So since this condition is true, I get a result. If I change that to an A, for example, then it would be false. So now I can get one letter of something. And I could check for the password instead of the name. So I could pump out one letter of the password this way. I see another question here. So name equals true. Yes, that's right. If the way this field works, if it finds a result, if there is a non-zero number of results, you'll see a message here. If there are no results, you'll see no message there. That's why this is how blind SQL injection works. You can ask one true or false question. And so if this condition is such that it is satisfied by at least one record, then you see a result. That's the idea. And by the way, of course, you have to test it early and find out what this is. I've seen ones where you get an error 500 in one case and a response of 200 code in the other case. It depends on the layout of the web page, what the two results are. Sometimes you'll see two different error messages, but as long as you can find something about the result that is different in the true and the false case, then you can perform blind SQL injection. And you can pump things out. So you'll be able to pump out ID numbers and passwords and social security numbers and so on from this database. It just takes a series of queries. And that's what I wanted to show you. So you should try this one about SQL injection, and that'll give you a good start. Now I'm going to stop this streaming and save this recording. Well, I'll stop the recording.